Okay, so number 30, you go to an amusement park with your friend Betty, who wants to ride the 30-meter diameter Ferris wheel. She starts the ride at the lowest point of a wheel that, as you face it, rotates counterclockwise. What is her displacement vector when the wheel has rotated by an angle of 60 degrees? Give your answer as a magnitude and direction. So let's start off with what we know. What we know is the diameter of this Ferris wheel is 30 meters, and so we know that the radius is 15 meters, just half of 30. And we know that we have a 60-degree counterclockwise rotation. So what this looks like on the Ferris wheel is this. This is kind of just a rough sketch of what we have here. So we're starting down here, and we're moving a 60-degree rotation counterclockwise and ending here. And we have the X and Y axis here just to kind of demonstrate kind of what we're looking at. And we're trying to find the displacement vector here, which we've called A. And we know that these lengths here are 15 meters each. And then over here, a slightly more in-depth figure of what we're looking at. We have A, and we have the 60 degrees, but we have also labeled all these other angles and sides. So we have little b and little c, and then big B and big C, and we have also big A for these angles and for these sides. And so what we're trying to find here is we're trying to find a magnitude and a direction. We already know that this side here, A, is our magnitude, but our direction is actually going to be the angle directly underneath of it, which is going to be theta. And so what we want to do is we want to find the magnitude, and then we can use the magnitude to find the direction. So first of all, we need to find A, the magnitude. We're going to use the cosine rule, which is a squared equals b squared plus c squared minus 2bc cosine of A, which is going to be A equals the square root of b squared plus c squared minus 2bc cosine of A. And these are all lowercase versions except for cosine of A here. Now we know all of this here, so we can just solve for A. So we have 15 squared minus 2 times 15 times cosine of 60 degrees. And make sure your calculator is in degree mode if you're using a TI calculator. And if we do all of this math and take the square root, we're going to get 15 meters as our magnitude, which is crazy because everything ends up perfectly even. Next, we're going to find theta, the direction. And so we're going to use that cosine rule again, but instead of finding A, we're going to find big B. And why we're going to find big B is because if we can find big B, the angle from here to here, then we can find theta by just taking 90 degrees and subtracting B. So we're going to have b squared equals a squared plus c squared minus 2ac cosine of B. So we're going to plug in all the 15 squareds here since we know what A is now. And then we're just going to do a little bit of algebra until we get cosine B equals 0.5. And so what we're going to do here is we're going to take the arc cosine, or the cosine inverse on your calculator, of 0.5, which is going to equal big B. And we're going to find that big B equals 60 degrees. And now what we're going to do is we're going to take 90 degrees minus B. So 90 degrees minus 60 degrees equals 30 degrees, which equals our direction. And so the answer to this question is 15 meters magnitude and 30 degrees direction. And what we learned here, what we're trying to practice in terms of our lesson goals, is vector algebra, component notation, and decomposition, because we're really trying to figure out different ways of finding these values, the values of this vector, because sometimes we want the x and y coordinates or the components, and sometimes we just want the magnitude and direction. This time we wanted the magnitude and direction, and so we were trying to figure out how to use our vector algebra, component notation, and decomposition from week 3. Thank you very much, and I hope you have a lovely day.